All right, welcome to our section on waves. In this section, we're going to be talking about how waves transfer energy, not matter, the difference between a mechanical and a light wave, and the difference between a transverse and a longitudinal wave. So let's go ahead and get started. First of all, what exactly is a wave? Well, a wave is a repeating disturbance that transfers energy through matter or space. Wave motion always transfers energy, but it's not going to transfer the matter from place to place. So it's not transferring the material that it's traveling through the medium. There are two different types of waves. There are light waves and mechanical waves. Now we already saw, or you have a podcast on light waves, so we are going to mainly focus on mechanical waves. Now mechanical waves must have a medium to move through. They transfer that energy through the particles of the medium. And as they're moving, the energy gets transferred, but not the medium. The medium is whatever matter that wave is traveling through, and it can either be a solid, a liquid, or a gas. The difference between this and a light wave is that a light wave can travel in a vacuum. It does not need a medium, whereas a mechanical wave needs a medium to travel through. Now we have two different wave types, and these are mechanical waves. We have longitudinal waves and transverse waves, and we're going to start with longitudinal waves. Longitudinal waves, the wave moves from left to right, so we can see there the cursor is moving from left to right. That's also the direction that the energy is moving in, so we have the energy moving in the same direction as the wave. Now in a transverse wave, the wave is moving up and down, kind of like a slinky, or what we would think of as a slinky, while the energy itself is moving from left to right. The first type of wave that we're going to talk about is a longitudinal wave or a compression wave. And an example of a longitudinal wave is a sound wave. And we're not going to spend a lot of time talking about them, but it is nice to know that a longitudinal wave is a sound wave. Now, there are two main components to a sound wave, so if you want to draw this in your notes, we're going to have a very tightly coiled area, and then we have an area that is more loose where the waves are spread out. And then we have a section that's all tight together, and then a section that is spread out. The areas that are spread out, where the wave is, the air molecules are really spread apart, is called the rarefaction. And this is the area where, like I said, where the air molecules are really, really spread out. Now we also have areas where the air molecules are going to be squeezed together, and this is called the compression. So our longitudinal or our compressional waves are made up of two pieces, the rarefaction and the compression. And a wavelength in this case is one compression to the next, or one rarefaction to the next rarefaction. The next type of wave that we're going to be talking about is called a transverse wave. And in a transverse wave, this is where the matter is going to be moving at a right angle to the wave. So a good example of this are ocean waves, where we have the water moving up and down, whereas the wave is traveling from left to right. Now, I can take my wave and I can kind of divide it in half, and we have some important pieces to this wave, so if you want to write that in your notes, that would be great. The very top of every wave is called the crest. The very bottom of every wave is called the trough. If I go crest to crest or trough to trough, that is called my wavelength. And for those of you that get tired of writing wavelength all the time, we have a nice symbol that we're going to be able to use that's going to represent the wavelength. And then if I take that middle line and I either go up to a crest or down to a trough, so I'm only really looking at half of that wave, that is called its amplitude. So this is in a transverse wave only, and I have those four main pieces, the crest, the trough, the wavelength, and the amplitude. And we'll actually be talking about a couple more words here in just a little bit, but that kind of gets us started with our longitudinal and our transverse waves. So the next thing we can talk about are wave frequencies. Now, frequency is the number of waves that pass a given point per second. So the number of wavelengths per second, that is a frequency, and it is measured in hertz, named after the gentleman that discovered that. And hertz can be abbreviated Hz. So our frequency is number of waves per second, and it is measured in hertz. So as my frequency goes up, my wavelength is actually going to go down. The distance between that crest to crest or trough to trough. So here's my wave. I've got my wavelength. Now here's another wave, and I'm going to put my wavelengths on it as well. Now the very top wave, that is going to be 1 wavelength per second. So I'm going to mark off the second mark here. And so it has 1 wavelength per second. So it is going to end up with a frequency of 1 hertz. The bottom wave, however, gets 2 wavelengths per second, so it is going to have a frequency of 2 hertz. So as my frequency went up, the distance between crests, my actual wavelength, goes down. So the next thing we need to talk about are periods of a wave. The period is the time for one complete wave to pass a point. It is measured in seconds, and as my frequency is going to increase, my period is going to decrease. So remember, frequency is number of waves per second. So the faster that this wave is moving, then the time that it takes for that wave to get past one single point is going to decrease. So in this podcast, we just got done talking about waves. We know that waves transfer their energy, not their matter. We know that mechanical waves are different from light waves in that they actually need a medium to travel through, whereas light waves do not. And we talked about the difference between a transverse wave and a compressional wave or a longitudinal wave. In that we talked about the specific parts, that rarefaction versus the compression in a longitudinal wave. And we talked about the crest and the trough in the transverse wave. Now, we both have wavelengths, or both type of waves have wavelengths, and they both have an amplitude. We also talked about how to determine the frequency of a wave and how to determine the period of a wave.